welcome to Learn to Expand. Here in this video there are two examples of solving the system of two equations using the inverse of a matrix. In each method of finding the answer to the system of equations, we have only a goal, and it is to isolate the variable and find the answer which is simultaneously satisfies both equations. Comparing with other methods, we know finding the inverse of a matrix is more complicated, and matrix multiplication is a longer process. However, it should not be forgotten, we can easily investigate our system in details by matrices. Other reason that will cause matrices to win over people's hearts is that they are handled well by computers. They are useful as data structures as well. So, matrix form is a form that is easily accepted as an input by computers. Okay, here's the first question. The first system contains two simultaneous equations. At the beginning, we will write the system in matrix form. And the matrix A is the coefficient matrix. And our coefficients are 4, 2, 3, and -1 here, okay? And the matrix is the matrix representing the variable of the system. And our variables are x and y, which is, this matrix is a vertical matrix, okay? Which is 2 by 1, because we have two variables. And the matrix B here is the matrix representing the constants. And our constants here are 5 and 0. Because we have two equations, is 2 by 1. It's a vertical matrix actually. Okay, so it's gonna be A times X, which is gonna be equal to B. And from here we can come to the conclusion that the matrix A is equal to A inverse times B. And from here we have X and Y, our vertical matrix of the unknowns, which is going to be equal to A inverse, which is this matrix here, and we're going to find the inverse of this matrix, which is going to be 1 over the determinant of this matrix, which is 4 times -1, which is going to be -4, minus 2 times 3, which is going to be 6, -4, minus 6 is going to be -10 overall. Okay, we're gonna multiply this by the adjoint of the matrix A here, which is gonna be equal to, switching the places of the elements in this diagonal, we're gonna have -1 and 4, and multiply these two elements by a negative. We're gonna have -2 and -3 here. Multiply it by the matrix B, the constant matrix here, which is 5 and 0. And okay, here we have got 1 over -10, and we need to multiply these two matrices. Okay, this matrix is 2 by 2, and this matrix is 2 by 1. So the answer is gonna be the vertical matrix 2 by 1. Okay, this is gonna be 2 by 1. And how we get the answer? -1 times 5, which is going to be -5, and plus -2 times 0, which is 0, and overall is going to be -5. Okay, and for the other elements, -3 times 5, -3 times 5, plus 4 times 0, which is 0, overall is going to be -15 here. And -5 over -10, it's going to be 1 over 2, and -15 over -10 is going to be 3 over 2. Then from here, come to the conclusion that the variable x is equal to 1 over 2, and the variable y is equal to 3 over 2. We can also check our answer and see if it is correct or not. So from here we have x 1 over 2, so 4 times x, which is 1 over 2, just gonna be this is gonna be 2, and 2 times y is 3 over 2, and this is gonna be 3, and 2 plus 3 is gonna be 5, which is correct. And in the second equation we have 3 times 1 over 2, which is gonna be 3 over 2, minus the variable y, which is 3 over 2. This is gonna be 0, of course. And now let's take a look at another example here. We have another system with these two simultaneous equations, 5x plus 3y, which is equal to -2, -3x minus y equals 2. Okay, first let's write the system in a matrix form. So we're gonna have the matrix of the coefficients, which is gonna be 5, 3, -3, and -1. Okay, this is the matrix A, and the vertical matrix of unknowns, and our unknowns are x and y, which is the vertical matrix. Okay, and the vertical matrix of constants, and our constants are -2 and 2. So we have a times x equals b, and x is gonna be equal to a power -1, a inverse times matrix B. Okay, from here we have the vertical matrix of unknowns, which are x and y, which is gonna be equal to 1 over the determinant of this matrix here, which is gonna be 5 times -1, -5, minus 3 times -3, which is gonna be -9, and -5 minus -9 is gonna be 4. So 1 over 4. And here we have the adjoint matrix of the A, okay, which is gonna be equal to, here we've got 5 and -1, and here we're gonna have -1 and 5, and multiply these two elements by negative, we're gonna have -3 and 3 here, -3 and 3 here, and multiply it by the matrix of the constants, which is -2 and 2. This matrix is 2 by 2, and this matrix is 2 by 1. Then the answer is gonna be 2 by 1, as can be seen here. Okay, let's multiply these two matrices. We're gonna have -1 times -2, which is gonna be 2, plus -3 times 2, which is going to be -6, overall -4. Okay, and here 3 times -2 is going to be -6, plus 5 times 2 is going to be 10, overall it is going to be 4. Okay, -4 over 4 is -1, and 4 over 4 is 1. And from here we can come to the conclusion that the variable x is -1 and the variable y is 1. Okay, and we can also check our answer by substituting it in these two equations. Okay, 5 times -1, which is going to be -5, plus 3 times y, which is 1, -5 plus 3 is -2. This is correct. And -3 times x, which is -1, is gonna be 3, minus y is 1, 3 minus 1 is gonna be 2, which is correct. So the answer of the system is found here, which is -1 and 1. And for the first question, it was 1 over 2 and 3 over 2.